let's read the instruction in here, guys, on how we can analyze this graph, okay? Olivia, let's read this one in here.
For the following exercises, use the graph to identify zeros and multiplicity.
Thank you, right? So we're going to identify the zeros and multiplicity. And also, in addition to that, we're going to figure out what is the equation for this one as well, okay? So let's see in here first, what are the zeros for such, okay? So, zeros, again, is synonymous to the x-intercepts, right? Now let's see, where are the zeros in here, okay? Giselle, where do you think are the zeros in here?
The x-intercepts.
The x-intercepts, where are the x-intercepts?
At 3 and
At 3, very good.
and then -2.
At -2,
And then -4.
and at -4. Are we good? Right, so those are the x-intercepts in here. Okay, putting in here. -3, -2, -4. Good? Right. Next one, how do we determine the multiplicities, right? Again, it just depends on if they are passing through or not, right? If they pass through the x-intercept, then we know that it's an odd multiplicity, right? Either 1 or 3, right? If it bounce back, rebound, or didn't pass through, there is even multiplicity, right? Typically 2. We get it? Right. So with this, at -4, what kind of multiplicity will that be? Thomas? 1. Very good. Multiplicity in here. 1 for -4. What about at -2? In that case, all right? Anna, what do you think? At -2, what multiplicity?
1.
1 as well. Very good. Now, look at 3. What's happening to 3 and what kind of multiplicity do we have for such? Anna?
Isn't it
2. Very good, right? As again, now at 3, at x equals 3, it went there, didn't pass through, but just bounced back, right? So that's multiplicity 2. Are we good? Right? So, check and check. But again, our goal for today, in addition to that, is, once again, how to determine the polynomial equation given its graph, right? Let's read the first step for such, all right? Aiden, go ahead.
Determine the zeros or x-intercepts of the graph.
Thank you, right? And we have identified those at 3, at -2, and at 4. Good? Get it? Okay. Step number 2, what do we do then? All right, Reagan.
Use linear factorization to determine its factors.
Thank you, right? And again, according to our linear factorization theorem, what we're going to do with the zeros or x-intercepts to get its factors? Linear factorization theorem, guys, it says that if you have 0, C1, C2, and so on, then your factors will be what? X minus C1, X minus C2, and so on, right? In short, what do you need to do with the sign? Flip it, right? Sign change, all right? Very good. So Madeline, what do you think will be the factor at 3?
X minus.
Very good, X minus 3. What about at -2?
X plus.
X plus 2, very good. And the last one at -4? X plus 4. Good. Again, that's our linear factorization, right? Whatever your x-intercepts are, sign change them, put x in front of them, then those are each of the factors. Get it? Okay. Now, let's read step number 3. All right, Magnolia, let's read step 3.
Consider how it intersects the x-axis and determine
Multiplicities, right? So in short, the powers, the p's, all right? The powers or exponents for each of those factors, okay? So with that being said, we said a while ago, x minus 3 is multiplicity what? 2, right? We good? Okay. And these two are each multiplicities 1. We good? They just pass through. Get it, guys? Okay. Good. Right. So those are the multiplicities. The p's, right? The exponents of each of them, right? Step 4. All right. Anne-Marie, let's read.
Multiply the function by a and solve this using the y-intercept.
Thank you. All right. So we're gonna put an a in front of it, right? And multiply it by a. So here it is, right? A times x minus 3, x plus 2, x plus 4. Don't forget the square for this, right? Is equal to what? Y. Right? And how to solve for a? Use the y-intercept, right? Let's locate in here where it hits the y-axis, okay? Jaden, can you see where the y-intercept is for this case? 3, very good, right? See that one? That's your y-intercept, right? So in short, what does it mean? Your x is 0, y is 3. Get it? So we're gonna put that one in there, the y-intercept. And we can solve for a using that, right? So let's put it in here as such. Okay. What's our y-intercept? 3, right? Is equal to a. And you see this excess, there will all be gone, right? So this will be what? Negative 3, square it, 2, and then 4. Get it, guys, what we did? Right. Again, the y-intercept is the value of y when all of those x's are zeros, right? Are we good? So in short, we'll just remove all of those x's and multiply all of the factors together, right? Negative 3, you square it, times 2, times 4. Get it? Okay. Calculator, what's that gonna be? Negative 3, square it, times 2, times 4. Calculators, what you gonna get from that, okay? 72, you got 72, guys. So this is 9 times 8. Very good, 72. A is equal to 3, right? And what do we do next, Candy? You just want that A, right? How do you get rid of 72? Divide, right? Very good. So express your answer in fraction, guys, right? What's that gonna be in fraction form, right? What's 3 over 72? In your Desmos, just click on the blue button, right? 3 over 72 in fraction. What will that be? 1 over 24? Thank you. So check, we are done with step number 4. We have solved for A. Get it? Step number 5, if it's needed, right? If it's not needed, then don't do it, right? Let's read this one in here. Olivia, expand. All right. If needed, right? If it's needed in standard form, which this one is not anyways, so no need to do that one, right? Let's read step number 6, okay? Eva, go ahead.
Rewrite f of x in standard form and verify by graph.
Thank you, right? And again, if it's needed in standard form, then please do write it in standard form. But if it's not, then just write the whole expression as it's on its own, right? So in here, what's the final answer? In fraction form, here it is. F of x is equal to your a, what's that again? 1 over 24. And then put in the 3 factors together, right? What are those? X minus 3 squared, x plus 2, x plus 4. Get it? Okay. Now, how do we verify it? Well, we can graph it. Get it? Okay, so let's see how the graph looks like, right? Let me just X this out and see how the graph looks like for such. Once again, it doesn't say standard form, so no need to box or foil, okay? But if it says standard form, then please do that, okay? So let's put it in here. 1 over 24, right? And what is this? X minus 3. Square it. Good. Next one, x plus 2. Oops. And the last one, what's that? X plus 4. Does it look similar to what we have a while ago? Well, let's see. Where are the x-intercepts? At negative 4, at negative 2, and at positive 3. Get it? Okay. Where's the y-intercept? Is it a 3? Yes. Right? So, as you may notice, this graph and our given graph a while ago is the same. Get it, guys? So once again, to increase definitely your confidence of life, how do I know that I'm getting it right? Well, you should see it visually by graphing it in your decimals or TIs. Right?